I'm making this video to re-demonstrate so that I can share the solution to lab manual page 12, number 4. So the question is asking for the height of the waterfall, and it provides the information such that we can draw this picture. So we have the height of the waterfall as one leg of a triangle. The initial angle of elevation of the woman looking up at the falls, which was 47.45. Degrees. And then we know that the woman walked forward 25 feet, making this distance 25 feet. And we know this new angle of elevation to be 49.72 degrees. And the question again is asking for the height of the waterfall, or to find h. So for this we have two different triangles that would be helpful for us to consider. The first one being the larger outer triangle right here, which I can highlight in a different color for us. So this triangle, this larger outer triangle. And in that larger outer triangle, we have the relationship between the angle measure, the height of the waterfall, and the total base as tangent of that angle, 47.45, equals h over x plus 25. Then the second triangle that we have, which I will highlight here in green, is right here. Using the other angle measure provided to us in the problem. So this triangle gives us a relationship of tangent of 49.72 equal to h over x. So now we have a system of equations that we can solve to find, well, both h and x if we wanted them, but the problem only prompts us to find h. So to solve that system, I'm going to choose to solve this equation for x so that I can substitute what I get into the other equation and have just an equation in terms of h. So if I solve the indicated equation for just x, we get x is equal to h over tangent of 49.72. And again, I'm going to take that and substitute it in for h up here in the original first equation. When we make that substitution, we get the following equation. Tangent of 47.45 is equal to h over tangent of 49.72 plus 25. So for convenience in writing this down, I'm going to make some substitutions here. I'm going to replace tangent of 47.45 with the letter A, capital A. And I'm going to replace the other tangent value with the capital B, just so that it takes less space to write. So the equation that I'm actually going to be manipulating is A equals h over B plus 25. and when I'm done at the end, I can just replace the a and the b with their appropriate values. So the goal is to solve this for h. So if we multiply both sides by h over b plus 25, so if we multiply both sides by this piece, we get a over b times h plus 25a equals h. I'm going to subtract a over b times h from both sides, so that gives me 25a equals h minus a over b times h. From here we can factor an h on the right, so that would yield 25a equal to h times 1 minus a over b. And we can divide both sides by 1 minus a over b to figure out what h is. So h would be equal to 25a over 1 minus a over b. And when you make the appropriate substitutions for the tangent values, so remember a is tangent of 47.45 and b is tangent of 49.72, we can get that h is roughly 800 feet. Oh, I'm sorry, not 800 feet, 340 feet.